Today I thought we'd take a look at the golden section search, which is something that's not always well answered in the exam or in assignments, but is a really easy algorithm and should be easy marks for you to get. So as the example, let's take the function f of x is equal to 1 minus x to the third minus x to the fourth, and we want to minimize this function over the interval 0, 3. Now you can have both min and max problems here. Sometimes people turn the min into a max or a max into a min size to apply the same algorithm, but it's really not necessary. It's very easy. At every step you just take the minimum in a minimization or the maximum in a maximization. So the first thing is to break up our interval into our search sections according to the golden ratio. Now we see the original interval as length 3, so we are going to use 3 times 1 over the golden ratio to give our interval lengths. Now this gives us a length of 1,854, which means our first interval is going to be from 0 to 1,854, and the second interval is going to be from 3 minus 1,854, which is 1,146, and it's going to go up to 3. Now to keep track of where you are in this algorithm, I always recommend drawing what you're doing. So in any mathematics really, when you can draw something, it gives you a lot more insight into what you're trying to accomplish. So here we now have 2 intervals, 1,146 to 3 and 0 to 1,854. And we're going to examine the values in these intervals. Now that means taking the function value f at 1,146, which gives us minus 2,2299, and the value at 1,854, which gives us minus 17,1879. Now since this is a minimization problem, we want to just get the minimum of these two, and we see it occurs at 1,854. Now we consider 1,854 to be in the interval 1,146 to 3, so our new interval of investigation becomes 1,146 to 3. And now we simply repeat what we did before. To take our interval, we need to get its length. 3 minus 1,146 is equal to 1,854. Don't be concerned if these quantities show up repeatedly, this sometimes happens. And then we need to take the inverse of the golden ratio, 0,618, and multiply by 1,854, which gives us 1,1458. So our 2 new intervals, we draw what we're doing here, start at 1,146 to 3. So we'll start with 1,146 plus 1,1458, which is 2,2916. And the other point to consider will be 3 minus 1,1458. What's that? That gives us 1,8542, which we can regard as being more or less there. And now we simply do the same thing. Now you'll see we have actually evaluated at this point. Here we have examine f at 1,854 before, and that was minus 17,1879. And now we still need to examine the function value at the other point, which is 2,2916, and that is minus 38,6117. Now again, we're looking for a minimum, and clearly this is the minimum value, which means the minimum will be attained closer to 2,2916, and that is in the interval 1,85423. So our new interval is 1,85423 and 3, and so on. We can just keep on repeating this procedure until we have performed the number of iterations required or reached the interval size we want. So once again, we simply take the length of this interval, you multiply that length by 0,618, let's just call this x and y for now, and then your two intervals to examine will be 1,185. That's 1,8542 plus y. Y only comes in the next part, so that will be 1,8542 and 1,8542 plus y, and the next interval will be 3 minus y and 3, and so we continue. You just keep following the same recipe over and over, and once again I encourage you to just summarize what you're doing all the time by drawing the intervals, because otherwise you have a lot of numbers on the page here, and without drawing them you might get a bit lost and take the wrong quantities. That's 3 minus y.